Okay, guys, we are ready for math. And what we're doing today is what you just saw with Mr. Walker. We're going to be dividing some. Our goal today is to divide word problems with remainders. That means there's going to be some left over. And, the idea today is just to kind of get you thinking about what division is, thinking about how you can solve it, different strategies. We're going to do a lot of picture drawing today. And then we're going to get into, by the end of the week, we'll be doing the standard algorithm for division, doing long division. But a lot of picture drawing today just to get us thinking about what is division, what are we actually doing when we're doing division. So I'm working the problem set here. These are very similar to the ones that you'll be doing in homework for today. So if you'll pay close attention, I think it'll make your homework very easy. And when you're doing your homework, you can draw pictures like this. You can use other strategies you've learned, but the idea is just to understand what a division is with remainders. So our first problem here says there are 19 identical socks. And I don't know how identical my socks are, even one's turned sideways there, but I tried to draw all the best I can. So I drew 19 socks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 socks. The first question says, how many pairs of socks are there? Well, we better ask ourselves, what is a pair? A pair means two, right? So if you got a pair of socks, that means you've got one for each foot when you put your socks on. So a pair of socks is two socks. So how many pairs are there? Well, the way I've drawn this, it's easy to see. We can group these in pairs pretty easily, kind of like the array that Mr. Walker was doing in the video. So here's one pair, two pairs, three pairs, four pairs, five pairs, six pairs, seven pairs, eight pairs, nine pairs, but we don't have another pair, do we? So how many pairs of socks are there? There are 9 pairs of socks. Okay? Will there be any socks without a match? That's just a yes or no question. Do we have any socks that don't have a match? A match. Yes. And then part C says, if so, how many socks don't have a match? We just have this one sock without a match. So what we were doing when we draw this picture and answer this question is if we want to write an equation, we have 19 socks and we divided them into pairs, divided them by groups of 2. And when we did, 19 divided by 2 is, we got 9 pairs with a remainder of 1. So 19 divided by 2 is 9, remainder 1. If we want to put it under the box, we can do it like that, 19 divided by 2. And we ask ourselves, how many times will 2 go into 19? What times 2 will give me pretty close to 19? Got to know your facts, remember. 9 times 2. We didn't divide it into 1, so we divided it into 19. So put it above the 9. 9 times 2 is what? It's 18. Then we subtract. 19 minus 18 is 1. We put that remainder up here. You see, we still got 9 remainder 1. We're going to learn these steps when we do the standard algorithm, but it's divide, multiply, subtract. And if we had another number, we would bring it down, but we don't. So our answers over here for this problem are right here, but the answer to the equation would be 9 remainder 1. Okay, let's look at question number 2 together. Question number 2 says it takes 8 inches of ribbon to make a bow. How many bows can be made from 3 feet of ribbon? Now, it already made it tricky here because it asks us it shows us in feet, but we have inches, so we have to do some conversion before we can ever get started. So 1 foot is 12 inches, so we have to figure out how many inches would be 3 feet. If 1 foot is 12 inches, then we have to do 3 times 12. So we have 36 inches that we're dealing with. We have a total of 36 inches, and it wants to know how many bows can be made from 36 inches if it takes 8 inches of ribbon to make a bow. So let's do this. Let's do groups of 8, okay? And I just drew a box here, kind of an array. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8. Okay, we'll do another 8. 1, 2, 3, 4, 5, 6, 7, 8. What's two groups of 8? 16. Let's do another group of 8. 1, 2, 3, 4, 5, 6, 7, 8. So let's make sure so we don't forget there's 8, there's 16. 16 and 8, another group of 8 would be 24. Let's do another group of 8. 1, 2, 3, 4, 5, 6, 7, 8. 24 and 8 more would be 32. If we did 8 more, we would go all the way to 40, but we don't have 40 inches. We only have 36 inches. So how many groups of 8, how many bows could we make from 36 inches? We could make 1, 2, 3, 4. So the first answer is we could make 4 bows if we had 36 inches. Then the next question says, will there be any ribbon left over? Yeah, we used 32 inches and we had 36, so the answer is yes. And then it wants to know how much. Well, we had 36 inches, so we'll do 36 minus, we used 32. 36 minus 32 is 4. We'll have 4 inches left. Okay. Let's move to the next problem. Number 3 says a library has 27 chairs and 5 tables. I drew our 5 tables here. 1, 2, 3, 4, 5. If the same number of chairs is placed at each table, how many chairs can be placed at each table? So we've got to take 27 chairs and divide it into 5. 27 divided by 5. So we're going to draw a picture here, okay? What do you think we should start with? Well, if we just do 1 in each box until we get to close to 27, that would work, wouldn't it? So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these little lines represent chairs. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We've got 27, remember. 21, 22, 23, 24, 25. Are we going to be able to do any more? No, because we have 5 more tables and we only have 27. So we put 5 chairs at each table, 5 chairs at each table, and that equals 20. We use 25 chairs altogether. So if the same number of chairs is placed at each table, how many chairs can be placed at each table? Well, we put 5 at each table. Will there be any extra chairs? Well, we had 27 and we used 25. So yes, there will be extra chairs. If so, how many? Well, we had 27, we used 25. Let's subtract. 7 minus 5 is 2. 27 minus 25 is 2. So there's 2 chairs left over. So that's how we answer that question. If we want to look at the equation, we do 27 divided by 5, gave us 5 groups of 5, and we had a remainder of 2 left over. Okay, now we put it under the box over here just to look at it. Oh, not 25. 27 divided by 5. You got to know your facts. What times 5 gets us close to 27? Well, we know it's going to be 5. 5 won't go into 2, but we can put a 5 here. 5, so we daddy divide, mama multiply. 5 times 5 is 25. Sister subtract. 27 minus 25 is 2, so 5, remainder 2. We get the same thing. You heard me say daddy divide, mama multiply, sister subtract, where it's just something where I've taught math, it's something I'll be saying a lot. Daddy, mama, sister, brother. Daddy divide, mama multiply, sister subtract, brother bring down. But we don't have a problem. We have to bring anything down yet, so I just did that automatically. Okay, number 4. The baker has 42 kilograms of flour. She uses 8 kilograms each day. After how many days will she need to buy more flour? So she's got 42 altogether, and every day she uses 8. how many days will she need to buy more flour? So I kind of set up, not really, but similar to an area model for this one, similar to what we did in the array, but I just thought this would be a good way to do this, a different way to model it. So I know on day 1 times 8 is 8. She used 8 kilograms of flour. On day 2, how many will she have used? 8 times 2 is 16. So in 2 days, she uses 16 kilograms. In 3 days, how many would she use? What's 3 times 8? 24. How many do we have? We've got 42. How many will she use in 4 days? What's 4 times 8? 32. We're getting close. How many will she use in 5 days? What's 5 times 8? 40. And she needs 8 for another day. Does she have 40? 40 plus 8 would be 48. Does she have 48 kilograms? No. So she can't make any more after day 5 because she will not have enough to use for the next day. So let's see what the question says. After how many days will she need to buy more flour? So after day 5, so after 5 days, because day 6, she would need 8 times 6, 48, and she only has 42. So she's going to need to buy more flour after day 5. Number 5, Caleb has 76 apples. He wants to bake as many pies as he can. It takes 8 apples to make each pie. How many apples will he use? I did the same thing here, except I did my boxes way too small. So I'm going to write sideways in them if you don't mind. So we're going to do the same thing. He has 76 apples, and it takes 8 apples to make each pie. How many apples will he use? Okay, he wants to use make as many as he can with 76 apples. So every one pie takes 8 apples. So one pie would take 8 apples. I know it's kind of small here. 2 pies would be 2 times 8 is 16. 3 pies would be 3 times 8, 24. 4 pies would be 4 times 8, 32. 5 pies would be 5 times 8, 40. 6 pies would be 6 times 8, 48. We've got 76, so we can keep going. 7 times 8, 7 pies would be 56 apples. 8 pies, 8 times 8 is 64 apples. 9 pies, 9 times 8 is 72 apples. 10 pies, 10 times 8 is 80. We don't have 80 apples, do we? So we can't make 10 pies. We can only make 9 pies because 9 times 8 is 72. So how many apples if it takes 8 apples to make each pie, how many apples will he use? So it didn't ask how many pies we can make. He can make 9 pies. Okay? But if he makes 9 pies, how many apples will he use? Well, what is 9 pies times 8 apples? He'll use 72 apples. But he doesn't have enough to make another pie, does he? How many apples will not be used? Well, he used 72 apples. He had 76, and he used 72. So let's find how many are left over. 76 minus 72 is 4. So there will be 4 apples not used for the pies. Maybe you can make some candy apples or some caramel apples with those. I like those, don't you? Okay. So that one was just a little bit different. That one asked it in a different way. So we've got to make sure we read carefully because it didn't say how many pies he could make. If it said how many pies he could make, how many pies would he have been able to make? He would have been able to make 9 pies, but that's not what it says. It says, how many apples will he use? He would use 72 apples to make 9 pies. Okay. Number 6, 45 people are going to the beach. I wish I was going with them, don't you? 7 people can ride in each van. How many vans will be required to get everyone to the beach? All right, so we can put 7 people in a van. Here's my vans. I just drew 8 vans, and we're going to keep going. If I need to draw more vans, I will. And we're going to put 7 people in each van, and we'll see how many we can get. So one van, 7. Two van, there's 7 plus 7 would be what? 14. 3 vans of 7. What's 3 times 7? 21. 4 vans of 7. 4 times 7 is 28. 5 vans of 7. 5 vans times 7 people is 35. Oh, we got to get 45. 6 vans of 7 people. 6 times 7 would be 42 people in these 6 vans. Oh, but we got 45 people. We're going to have to use one more van, aren't we? Okay, so these 6 vans will be 42 people, all of these together. But we're going to have to get 45 people, so we're going to have this van over here. How many people are going to be in it? We're going to have 3 more because 42 plus 3 is 45. So we'll use 6 vans of 7 people and 1 van of 3 people. Let's see what the question asks. How many vans will be required to get everyone to the beach? Well, it's going to take all 6 of these plus 1 more. So it's going to take 7 vans if we've got 45 people. Because we can't cram those 3 people in there. That vans only hold 7 people. So we've got to have another van for those 3 people. Okay? All right, I want you to try it on your own. Get some notebook paper, whatever you need just to draw you some pictures to answer your questions on your homework today. It's kind of fun. It's kind of like art math and doing some drawings with your math. So have a good time with it, and I think you'll do a great job. Go ahead and get started on your math.